Bismillahirrahmanirrahim. In this very short video, I'll try to explain the difference between line voltage and phase voltage, because there are many students who are very confused, and it's because the books are confused, have created confusion actually for the average students. So I'll make an effort. Now basically, when we talk of the generating system or distribution systems, if you keep in mind three generators making the three-phase system. So one generator for each phase. Now, if the connection is in this manner as shown here, this is called the Y connected source. You can see this is like a Y, inverted Y. And in this, there is a point which we call the neutral point. The other 3 points, A, B, and C, they are the lines. So this is one line, line A, this is line B, and this is line C. The other connection is if we connect the three generators like this, so this will be called delta connected system. Okay, now let's discuss the Y connected system first. The voltage between line to line. So this is one line, this is second line, this is third line. Between line to line is called the line voltage. Actually, it should have been called line to line voltage. Anyway, so this is one line voltage. This is another line voltage. And the third line voltage will be between C and A. Now the phase voltage, always remember, it is just across one element. So across this one generator is the phase voltage. Similarly, across this other generator is a phase voltage, and also across this is a phase voltage. Now the phase voltage is actually between the generator and the neutral line. So this is one phase voltage, this is second phase voltage, and this is third phase voltage. Now, how do we relate these two? Obviously, line voltage is greater than the phase voltage. And anything greater in this chapter of power, you can just multiply it by under root 3. So first of all, we have to multiply it by under root 3. And then we have to add an angle 30 with the phase angle to get the line voltage. That means V line is under root 3, V phase angle 30. So this is the formula. And sometimes we are confused as to what is the magnitude. So when you talk of somebody about three-phase voltage, then you will know that the three-phase voltage is generally called 380 volt. But single-phase voltage in our country, as you know, it is 220 volt. So this is phase voltage. And if the question is asked only about the magnitude of the line voltage and phase voltage, then we just neglect this angle. This is the relation between magnitude of line voltage and phase voltage. In case of a delta, it is very simple, because as I have mentioned, that voltage across any one element is the phase voltage. So this is the phase voltage. But here it is also the line voltage between line A and line B. So this is line voltage. That means the phase voltage and line voltage are equal in case of a delta connected system. So V line is equal to V phase in delta connection. Whatever is the magnitude of this or the angle of this, same angle, same magnitude in both cases. Now, phase sequence we should understand. Three generators are connected in angular terms. They are 120 degrees apart. If we take VAN as the reference point with angle 0, then and we go clockwise to the next, which is VBN. So how do we go from VAN? We have to subtract 120 to go to VBN. So VBN is VP minus 120. Now VP is again very confusing. Just keep in mind this is 220 volt. So VBN will be VAN minus 120. What about CN? If we go like this, we have to add another 120 or minus 120. That means from VAN by minus 240, we can reach VCN. So VCN is VP minus 240. Now there's another way of reaching VCN, and that is, instead of going the negative side through this, we can go from here directly. So positive. So VAN plus 120 will also take us to VCN. So you can use any of the techniques, either by minus VP 240 or plus 120. Okay, now this is the example. Let's solve this. A positive sequence 3-phase balanced Y voltage source has a phase voltage of 240 angle 90. So V phase is 240 angle 90. And we have to now determine the line voltages. That means all three line voltages. So first of all, let's just put in the equation V line under root 3 V phase. V phase is 240 90. Multiplying, we get this value, and adding the angles, we get 120. So this is V line. Now, what do we call it? So we are using this formula. AN is given, so we'll call this as AB. So this is our VAB. VAB is now our reference. From here, minus 120 will take us to VBC. And again, another minus 120 will take us to VCA. So VBC is whatever is this with this minus 120 will go to VBC, and minus 240 will take us to VCA. Now, question. We went to VCA by subtracting minus 240. Can we get the same answer by adding 120? So following this part, so let's see. If we add 120 with this, the reference voltage, then we get plus 240. Now plus 240 is not same as minus 120, so they are not same apparently, but actually they are. Now the easiest way is that you add 360 with this, then you will get, adding 360 you get 240. So they are same. Now what is the implication of adding 360? Actually it does not change the magnitude. First of all, let's say we were here by minus 120. If we come here at this point, and if we with this point, if we add 360 plus 360, then we take a complete circle and we again reach at that same point. So this way we are calling it minus 20. This way we'll call it plus 240. So it's the same. I hope this has given you some kind of an understanding. Thank you.